Okay. Hello everyone. Good evening all. Welcome to YouTube session 11. The topic differential equations 1 engineering mathematics. In the previous sessions we had done 10 sessions on the topics linear algebra, matrices, numerical methods, differential and integral calculus, followed by vector calculus. Now this is differential equations, two parts, part 1, part 2. It doesn't mean that like that part 1, part 2. So 1 means first order differential equations. 2 means higher order differential equations. So a few definitions we have to learn. An equation which involves differential coefficients, which is other name derivatives, is called a differential equation. So derivatives are of two types: ordinary derivatives, partial derivatives. The derivatives with respect to only one independent variable is called ordinary derivatives. With respect to more than one independent variable, such derivatives are called partial derivatives. Previously in the calculus we have learned. Similar, an equation involving ordinary derivatives is called ordinary differential equation, short form ODE. An equation involving partial derivatives is called partial differential equation, short form PDE. Okay. Usually, how you identify in general many of the problems, if they do not mention in the question, as far as the derivative is concerned, the numerator variable is called dependent variable. The denominator variables are called independent variables. So here, one dependent variable y, one independent variable x. That is the derivatives with respect to x. So this is a ordinary differential equation example. Here, numerator variable u dependent variable, denominator variables x and y are independent variables. So this is a partial differential equation. Okay. Now, the definition 2 before definition 3, it is not required generally. Just for knowing purpose, I am explaining definition 2. Our intention or aim is to find the solution of a differential equation. What is the meaning of solution? It is a relation between the variables of the given equation which satisfies the given equation. Such a solution containing usually one independent variable, one dependent variable as far as ordinary differential equation. Okay. As far as partial differential equation, one dependent variable, either one independent variable or more than one independent variable, along with arbitrary constant. Some people that is also called constant of integration. So the next definition before definition 3 is general solution. A solution in which the number of arbitrary constants is equal to the order of the differential equation. Such a solution is called general solution. I mean, some people call complete solution also. But I don't accept that complete solution. I want to call general solution. In the general solution, if you give some values to the arbitrary constants, the solution so obtained is called particular solution. So usually the arbitrary constants denoted by C1, C2 or K1, K2, A, B, C, etc. Okay. Now definition 3. The order of the highest ordered derivative. But it is sufficient to write highest derivative. Many people can understand what is the meaning of highest derivative. But in textbooks, they gave like this. Highest ordered derivative is called the order of a DE. Once order exists, the power of the highest derivative, please underline power. Here this is order, highest derivative, is called the degree of a dE, provided there is a restriction or condition to find the degree. The differential equation, dE is the short form of differential equation, is free from radicals and fractions as far as the derivatives are concerned. So in your differential equation, see any derivative, whatever the derivatives present in the given equation, it should be free from radicals and fractions. That means in your given differential equation, if there is a denominator terms, it should not contain any derivatives, that is called fractional derivatives. If there is a derivative in the numerator or denominator, if there is a derivative in the numerator or denominator, it should not under square root or cube root or some sine function or some log function, that is called example of radical functions. Okay. So once you remove these radicals and fractions in all the derivatives concerned, then finally you will be getting your differential equation is a polynomial form. You know the meaning of polynomial. Each term having the power is a natural number. For example, x plus x square, it is a second degree polynomial in x. Similarly, all the derivatives should bring into the form of polynomial. Then only degree is defined. The power of the highest derivative. Let us see the example provided here. The order and degree of a dE, d cube y by dx cube plus 4 times under root, that is square root, 1 plus dy by dx whole cube is equal to 0 r. Here highest derivative is third order derivative. This is. So order is 3. It takes just 1 second or 2 seconds for finding the order. But for finding degree, all derivatives should free from radicals and fractions. There is a first derivative under square root. So this square root is an example of radical. So immediately we have to remove this square root. How? Shift this square root term to the right side and then squaring. Here square root is radical as far as the derivative is concerned. Squaring on both sides, you will be getting this. So this is highest derivative. The power of this highest derivative, this is 2. Okay. So that is degree 2. Order 3. I hope that everyone following understood. So here the definition 2 is a relation between the variables of the given differential equation which satisfies the differential equation is called a solution of the differential equation. Okay. A solution in which the number of arbitrary constants, fixed constant, you know, constant takes only one value which has no change. That is called constant or fixed constant. Arbitrary constant means it is also called constant of integration. It can change, yes, vary, which we have learnt in indefinite integration, is equal to the order of a dE. dE means differential equation, is called the general solution. Usually short form it is written as GS. So a particular solution is obtained from the general solution by giving some numbers, that is particular values to the arbitrary constants in the general solution. Okay. Now definition 4, linear and non-linear. A differential equation is said to be linear if the dependent variable and its derivatives occur only in the first degree. For example, here y is dependent variable. Third derivative having power degree 2. It is not power 1. So this is a non-linear example. Here, first order derivative dy by dx, where y is dependent variable. In this, the power of the first derivative is 3. So which is a non-linear. Linear means degree 1. and these derivatives are not multiplied together. That is, dependent variable should not multiplied by its derivatives, or any two derivatives of the same dependent variable should not multiply. Then only the differential equation is called linear. Otherwise, it is called non-linear. I hope that everyone understood linear meaning. For example, in the above problem, if I take y is dependent, x is independent. So this is an equation. So third derivative having more than power 1, first derivative having more than power 1. So it is not of power 1. So it is a non-linear. Even third derivative having power 1, first derivative having power 1. Then if these two are multiplied, or a dependent variable y is multiplied with any one of these derivatives, such an equation is called non-linear. Okay. Now let us see an example. dy by dx plus y is equal to e raised to x. Here I didn't mention which is dependent, which is independent. So as far as the derivative is concerned, that is dy by dx, the numerator variable y is taken to be generally dependent, x is taken as independent. So y power 1, it's the first derivative having power 1. These two are not multiplied. Other term is a x term where x is independent variable. So that's why is a first order. Highest derivative is 1, first order. Linear equation in which variable? Y. So linear equation we are talking about in dependent variable only. Why? Because see here definition, dependent variable and its derivatives. When we are talking a differential equation is linear, we should first concentrate on dependent variable and its derivatives. Now coming to this second example, third order derivative is there, second order derivative is there. Numerator f is taken as dependent variable, denominator n is taken as independent variable. So third derivative having power 1, second derivative having power 1, the dependent variable f having power 1. So all these are having degree 1. But dependent variable f is multiplying with its second derivative. So that's why it is a second order. I mean, highest derivative is 3. Third order non-linear equation. Previous one is first order linear equation. The here third order non-linear equation in f. Okay. Now, how to find the solution? First of all, first order equations. An equation of the form dy by dx is equal to f of x comma y. Equation 1. So in this differential equation, this is first derivative, highest derivative is 1. This dy by dx having power 1. Okay. So first order and first degree. Such an equation is called first order and first degree DE. DE stands for differential equation. So all types of this form, that is all differential equation of this form, cannot be solved. Only those among them can be reduced or converted to the following categories. Categories means types, name of the equation. Solved by the standard methods. Standard methods means there is a standard procedure when we have a first order first degree equation is some category. Category means types, some of the types, variable separable form or linear equation method or Bernoulli equation method, that is one by one. That is called categories. Each category having a procedure is called standard methods. That is, okay. See, the first one is type 1 method, type 1 category, variables, separable form. Okay, the name itself is there. We are separating the variables. So these are ordinary differential equations. So we have exactly one dependent variable and one independent variable. Let us take dependent variable is y and x is independent usually. So all y terms with dy are at one place. All x terms along with dx are at other place or another place. Such arranging is called variable separable form of the given differential equation. Now mathematically or notational method, see. All x terms are denoted by phi of x multiplied with dx. All y terms are denoted by psi of y multiplied with dy is equal to 0. So they are at the first position, second position of the left side, right side 0. Some people writing all x terms in the left side, all y terms in the right side. So this is called variable separable. After that, integrating both sides, you will be getting one time integration. That means one derivative. This is first order derivative. When we integrate, the derivative integration got cancelled and you will be getting the solution. In the last step, adding c. That C is called arbitrary constant or constant of integration. Some people call parameter. So don't think that every first order derivative having the solution which is obtained directly by integration. There are some methods. If you are getting the solution directly by integration, then what is the purpose of studying these methods? I hope that everyone following. Now, so when we are not making the given problem into variable separable, that means when we are unable or difficult to write the given differential equation into variable separable form, that is like this, then there is a substitution method so that the given differential equation can be reducible to VSF. Not all the problems. When we have the given differential equation like this, the left side is dy by dx and the right side function of ax plus by plus c. So this inside term ax plus by plus c is a linear term. Okay, straight line equation form, which is operated by f. For example, cos of x plus y. That cos is a function f. X plus y is nothing but ax plus by plus c, where a, b, c are constants. Such type of this differential equation kept in box can be reducible to VSF. That is, what is the short form? Variable separable form. VSF, that is full form is variable separable form. Okay. In short, we are writing VSF. By the substitution, ax plus by plus c is equal to t. Let us take this substitution by star symbol. This is asterisk, means instead of equation 1, I took some star equation. Once we took the substitution, that means once the substitution done, then differentiate with respect to x, y. The quotient in the first, that is the differential equation, where the left hand side is dy by dx, that is differentiation with respect to x to the y variable. So that is why in this substitution we should differentiate with respect to x. So a into x derivative with respect to x is 1 plus b into y derivative with respect to x is dy by dx plus constant derivative is 0. From this, find dy by dx. You will be getting and the right side t derivative with respect to x is dt by dx. So from this, dy by dx giving 1 by b into dt by dx minus a. So this is important, that substitution. Please highlight, please underline ax plus by plus c. So we'll do one example. This is a gate question. Which one of the following choices, that is options, is a solution of the differential equation given below? C is arbitrary constant. So in the question itself is mentioned. So the differential equation is given dy by dx plus y square upon x plus y upon x minus 2 upon x. 4 options ABCD given. So in the right side, all the denominators are same and it is x. So I want to shift the denominator dx of the left side to the right side. And after taking LCM x, your numerator is all y terms of the right side, which bring into the left side becomes division. Okay. So DE, that is differential equation, implies, that is can be written as dy by y square plus y minus 2 is equal to dx by x. So this is phi of y terms, this is psi of x terms. If you compare like that, this is VSF, full form, variable separable form. And depending on the integration, we should use the methods, that is in the last classes, calculus, properties of definite integrals, or substitution method, or by parts, or standard integrals, or partial fractions, etc. So what are the two linear factors for this after factorization? You will be getting y plus 2 into y minus 1. Okay. So this is, sometimes you need partial fractions, 1 by y minus 1 into y plus 2, or you can write y plus 2 into y minus 1. Both are non-repeated, that is distinct factors, linear factors, each term having power 1. So accordingly, the partial fractions is a by y minus 1 plus b by y plus 2. After taking LCM on the right side and cancelling both denominators and comparing the like terms, you will be getting AB. So that is here A value is 1 by 3 and B value is minus 1 by 3. Later you check. This is simple solving partial fractions. Since by partial fractions. Now back to this, integrating along with partial fractions. So 1 by 3 take out 1 by y minus 1 dy minus 1 by 3 1 by y plus 3 sorry y plus 2 dy is equal to 1 by x dx. So we should add c. Depending on the options, that is situation of the options, we should add sometimes log c or minus log c or 1 by 3 or 1 by 3 is common. Many of the integrations in the pre-position. So you can take plus log c or 1 by 3 log c, whatever you want. So I want to denote 1 by 3 log k. Okay. Or take log k. Log k means basic logarithm. Because all these are integrated, after integration you will be getting logarithms. That's why instead of constant I took log k. Why? Because using properties of logarithm we can eliminate logarithm. But no option containing logarithm, that's why I took log k or 1 by 3 log k. So 1 by 3 log y minus 1. Okay, 1 upon y with respect to y integration is log y. Okay, so that 1 by y minus 1 integrating with y is log y minus 1. You can compare with in the previous calculus integrations method f dash x by fx also. Minus 1 by 3. This is log y plus 2. So both are correct. I am writing sometimes log, sometimes ln. This is equal to log x plus 1 by 3 log k. So eliminating first 1 by 3s. Using properties of logarithms, log m minus log n is log m by n. So you will be getting in the left side log y minus 1 plus divided by y plus 2 is equal to, this is, there is no log here. Using properties of logarithms, a log b is nothing but log b to the power a. The pre-multiplication number will become into the power. So it is k times x cube. Okay. Or log of k times x cube. Eliminating logarithms, y minus 1 is equal to, after eliminating logarithm, shift the denominator of the left side to the right side. You will be getting like this. So this is k times x cube into y plus 2k x cube. Depending on the option, we should simplify further. Otherwise, after this integration, if this answer is in the options, you can leave. That is, sometimes the problems will be disturbed like this. So bring all y terms to the left side, take and then take y common. So y into 1 minus k times x cube. So shift this minus 1 of the left side to the right side will become 1 plus 2k x cube. And dividing the coefficient of y, you will be getting y is equal to 1 plus 2k x cube divided by k times, that is 1 minus k times x cube. Do you have this type of answer in the options? We have C. So dividing numerator means NR and DR denominator by K. See, short form of numerator is NR, short form of denominator is DR. So you will be getting y is equal to 1 by k plus 2x cube divided by 1 by k minus x cube. So which implies I want to denote now 1 by k as some other constant c, because k is a number. So 1 by k is also another number which is denoted by c. C plus 2x cube divided by c minus, where c is equal to 1 by k, comma, is the required GS. GS means general solution. So any option? So accordingly, option D is the answer. Very, very important, tough problem. Let us have a look another geometrical interpretation or another application oriented problem like that. So this is also gate question. A spherical naphthalene ball exposed to the atmosphere loses volume at a rate proportional to its instantaneous area due to evaporation. Full stop. If the initial diameter of the ball is 2 centimeters, that is cm means centimeters, and the diameter reduces to 1 centimeters after 3 months, comma, the ball completely evaporates in 4 options ABCD given. So this is a application oriented problem. Solution. So in the chart, many people, hello sir, that is everyone. Once again, I am telling you, hello everyone. Good evening, everyone. So spherical naphthalene ball, we know that it looks like sphere only, having radius, diameter, you know. So diameter is equal to twice the radius, or radius is equal to half the diameter. So usually volume is denoted by V, area is denoted by A. So given the verbal language converted into mathematical language, dV by dt proportional to capital A. So you know that growth and decay, when it is reduces, removing proportionality constant, that is removing proportionality symbol multiplied by the constant with minus. Generally the problems, when it is a growth problem, you should multiply the constant k after removing the symbol proportionality constant. So where V is equal to 4 pi by 3 r cube is volume of spherical naphthalene ball. Capital A is equal to 4 pi r square is area, that is total surface area of spherical ball. So from this, dV by dt is equal to minus k times A. So derivative with respect to t for volume, here r is a variable. So 4 pi by 3 is a multiplication constant, take out, which will not be affected after differentiation. R cube derivative into 3r square, but we are differentiated with respect to t. So you should multiply dr by dt minus k times area, that is 4 pi r square. After cancelling 3 and then 4 pi r square on both sides, you will be getting dr by dt is equal to minus k. So where r is considered as dependent variable, t is considered as independent variable, easily expressed as variable separable as dr is equal to minus k times dt, which is variables separable form. So integrating, we get integral dr is equal to minus k constant take out integral dt plus c. So this implies integral dx is x, so that integral dr is r, integral dt is t, so minus kt plus c. Let us denote this is equation 1. Now go to the conditions. Instantaneous area means that is initial diameter of the ball. That is the ball at the initial stage having diameter is 2 centimeters. So given r is equal to 1. R is nothing but d by 2. D is nothing but diameter. When initially means that is time t is equal to 0 and it is reducing, that is diameter reduces to 1 centimeter after 3 months. That is, please underline, these are called initial conditions. And r is equal to 1 by 2 when t is equal to 3 months, comma 1 gives, that is equation 1, substituting these conditions in equation 1, you will be getting k and c values, constants. So 1 is equal to directly c answer, and r value half is equal to minus kt minus 3k plus c value 1. So this simplifies to 3k is equal to 1 by 2, k is equal to 1 by 6. We got by this step k value and initially c value. Therefore, r is equal to minus t by 6 plus 1. Now they are asking ball completely evaporates. That means it is reduced to point sphere. It want to become point sphere, that is radius 0. When they are asking in how much time? When r is equal to 0, comma, time t is equal to question mark, that is we are going to find, comma, equation 1 gives, again back to in equation 1 substitute, 0 is equal to minus kt, that is minus t by 6 plus 1. Or you can say this is equation 2. Then you can write 2 gives directly. So from this, t is equal to 6. That is 6 months. So in 6 months, the ball completely evaporates. Accordingly, answer is option A. I hope that everyone understood and good following. Okay, we'll move to second method. That is second category or second type. Yes. Linear equation. The equation, I told you already, linear equation means dependent variable and all its derivatives having degree 1 and no two of these terms multiplied together. Okay. So dy by dx plus p into y is equal to q. First, you have to know or remember p comma q are functions of x. Don't say functions of x or functions of z like that. Observe dependent variable, independent variable. So in this dy by dx, your denominator is x. So always p comma q are functions of independent variable. Everyone remember, p comma q are always functions of independent variable or constants. So that is p comma q are functions of x or maybe constants. Is called first order, highest derivative is 1. Linear equation. In which variable dependent variable is y. Some people call Leibniz linear equation. Leibniz is a scientist. So here in this box, equation 1, power of y is 1. It's a first derivative having power 1. These two terms not multiplied. Other terms p comma q, which doesn't contain y variable, which contain either constant or functions of denominator variable x. That is function of x. So once you bring your differential equation into this standard form, that is dy by dx plus py is equal to q, immediately general solution to be considered as a formula, so that we are saving the time. Just y into if is equal to integral q into if, integrating with respect to x, that is dx, plus c, where if is equal to e raised to integral p dx. This is called integrating factor. So if is the short form notation of integrating factor. Please by heart solution and standard form equation 1. Now, in the above equation 1 and its general solution, wherever x and y, just interchanging x and y, you will be getting first order linear equation in x, that is dx by dy plus p into x is equal to q, where p comma q are functions of y. Earlier it is x, because in dx by dy, y is denominator, that is independent variable, or constants, is called first order linear equation in x. The general solution, in this general solution above, interchanging x and y, you will be getting x into if is equal to integral q into if dy plus c, where if is equal to this one. Please by heart. So this is an example gate question. The value of y as x tends to infinity, please underline. This is a condition given. For the following differential equation for an initial value of, that is y of 1 is equal to 0, which means y value 0 when x is equal to 1 is dash. The differential equation given 4x squared plus 1 into dy by dx plus 8xy minus x equal to 0. Solution. Let us check the previous variable separable method is applicable or not. So I can't write, that is x terms alone into dx and y terms alone into dy. Okay, because there is here minus x. If I shift this minus x into the right side and multiplying by dx, this y term is also multiplying by dx. So it is not variable separable. So this is not variable separable form. Now let us compare the linearity. Here the derivative is dy by dx. So first give the priority to y variable, where the numerator variable y power 1, no other y terms, and y derivative with respect to x dy by dx having power 1. This y is not multiplying with first derivative. So I can confirm or say this is the first order linear equation in y. So please remember, in both notations, derivative coefficient is always 1. Here dx by dy coefficient 1, here dy by dx coefficient 1. But here, this is a 4x square plus 1. So immediately what we have to do in the first step, dividing both sides by 4x square plus 1. So I can write dg differential equation can be written as after dividing by 4x square plus 1 dy by dx plus 8xy divided by 4x square plus 1 can be written as 8x by 4x square plus 1, want to put in the bracket and keeping y outside, looks like standard form of p into y in the linear equation y, and minus x shifting into the right side becomes plus x. After dividing by 4x square plus 1, it becomes x by 4x square plus 1. Let us denote this is equation 1. So this bracket is p and this term is q. Clearly p comma q are functions of x. So this is first order linear equation in y. Okay, I hope that everyone following. Understood. F means first, O means order, L means linear, E means equation. The next step is finding integrating factor, that is IF. E to the power integral P dx. So according to methods of integration, it looks like f dash x by fx. 4x square plus 1 derivative with respect to x is 8x. So e to the power log 4x square plus 1. E log cancel will give contradict to each other. 4x square plus 1, that is if. So here I used the formulas integral f dash x upon f of x dx is equal to log mod fx, and e to the power log of fx is nothing but simply fx according to logarithm exponential definition. After finding if, the general solution, that is short form GS, is y into if. If how much? 4x square plus 1 is equal to integral q. Q how much? X by 4x square plus 1 into if, that is 4x square plus 1. Integrating with respect to x, that is dx plus c. So this is if integrating factor, and this is q, and this is if. So on the right side, 4x square plus 1 cancel. Simply you will be getting x dx plus c. So which is nothing but x integration with respect to x is x square by 2 plus c. Let us denote this is equation 1. Now we have to determine the constant c by using the given conditions. Y value 0, x value 1, that is y of 1, 0. Using y of 1 is equal to 0, that is y value 0 when x is equal to 1, comma, equation 2, that is solution. General solution gives left side 0 into anything is 0, and the right side x value 1, 1 by 2 plus c. From this c value is giving minus 1 by 2. So therefore y into 4x square plus 1 is equal to x square minus 1 by 2 after substituting c value and taking LCM 2. So this I can write y is equal to x square minus 1 divided by 2 into 4x square plus 1. But they're asking the value of y, that is solution value, as x tends to infinity. So taking x tends to infinity, we get y is equal to limit concept, that is x tends to infinity. In the problem's limits, which you have learned in the calculus beginning, when x tends to infinity, take out the highest powers of x, that is converting into reciprocal terms. So here numerator highest power of x is x square, take out 1 minus 1 by x square. In the denominator is also x square highest, so 2 into x square into 4 plus 1 by x square. These two cancel. In the remaining terms, put x is equal to infinity, 1 by infinity 0. That is the purpose we convert into reciprocal terms. 2 into 4 plus 0. So this is 1 by 8. So the value of y is 1 by 8. Answer is 1 by 8. The last method, when the given problem is not solved by variable separable or linear equation, can be solved by Bernoulli's equation, that is non-linear equation in y. Type 4, Bernoulli's equation. Actually, this is type 3, previous one type 2. The equation dy by dx plus p into y is equal to q times y power n. If I remove this y to the power n, which is nothing but the previous method linear equation in y. So where p comma q are functions of x are constants and n not equal to 1, why it is not equal to 1, that I will explain in the procedure, is called Bernoulli's equation. So please highlight, this is extra term. So this is non-linear equation. One of the example of non-linear equation, Bernoulli's. Bernoulli is a scientist. See, back to previous one. This is linear equation y. The right side only q. But Bernoulli, the right side q multiplied by some other y terms. Okay. This equation 1 is reducible to linear equation. How? Dividing both sides by y power n. Why? Because In the right side of the previous linear equation is q only. So after dividing both sides by y power n, the first term dy by dx now becomes 1 by y power n dy by dx, nothing but y power minus n, because 1 by y power n can be written as y power minus n into dy by dx plus p into y by y power n can be written as y power 1 minus n, because a power m by a power n is a to the power m minus n is equal to right side q. Now the right side q of the linear equation, left side p into y power 1. So instead of y power n, we have y power 1 minus n. To make power 1 variable, we should take substitution method, that is called change of variable. So put y power 1 minus n is equal to u as you wish. Some people taking t, some people taking z. So when you take the substitution in previous methods, I told you differentiate with respect to here. Independent variable is x. So that's why differentiate with respect to x. So the left side y power 1 minus n looks like x to the power n form. X to the power n derivative n into x to the power n minus 1. Now this term y power 1 minus n derivative is 1 minus n into y to the power 1 minus n minus 1. Because we are differentiating with respect to x, we should multiply by d by dx. And the right side u derivative with respect to x is du by dx. So here in the left side power 1 minus 1 cancelled, and shift this 1 minus n multiplication factor constant to the right side. You will be getting y power minus n dy by dx is equal to 1 upon 1 minus n into du by dx. So this term substitute in the equation 1, I mean in this equation. Okay, you will be getting this y power minus n dy by dx is 1 upon 1 minus n du by dx plus p into u is equal to q. We are almost linear equation. After multiplying this 1 minus n, that is eliminating 1 upon 1 minus n, multiplying both sides by 1 minus n, you will be getting du by dx plus p into 1 minus n into u is equal to q into 1 minus n. But I denoted p into 1 minus n is p1 and q into 1 minus n is q1. So by heart this step, that is where I put double tick this one, this one, this one, and this substitution method. These 4 boxes are sufficient. Before that, the standard form. Then without writing all these steps, we can easily solve this. Why this condition n not equal to? See here, after dividing this 1 minus n, because of this denominator 1 minus n, generally denominator not equal to 0 or not, denominator constant. 1 minus n is a constant, it should not be 0. If 1 minus n not equal to 0, that means n not equal to 1. So in this discussion, interchanging x and y, you will be getting the Bernoulli equation in x, just like linear equation in x. So example, gate question. The solution of dy by dx plus x into y is equal to x upon y, comma y of 0 is equal to 0 is. So the right side x is multiplying by 1 upon y, that is y power minus n minus 1, which looks like y power n. So dy by dx plus x into y is equal to x into y power minus 1. Why I put the text terms in the bracket? Because of comparing and then identifying our Bernoulli equation will give directly p and q. So this x is p, this x is q, p comma q are functions of x. From this, you will be getting n is equal to minus 1. So this is equation 1 is Bernoulli's equation, short form BE. In which variable? Y variable. Okay. So I hope that you remembered equation 2. As I put double tick steps, du by dx plus p1 into u is equal to q1. Let us say equation 2, where first of all the new dependent variable u connected with old dependent variable 1 minus y to the power 1 minus n becomes y square, because n is equal to minus 1. And p1 is equal to p into 1 minus n. P value x, 1 minus n is 2, so 2x. q1 formula q into 1 minus n. 1 minus n is 2, q is x, so this becomes 2x. So this equation 2 now is a first order linear equation in which variable u instead of y. Y is previous original dependent variable, but new dependent variable is u. So we know how to solve as before, as discussed earlier. So next step is finding if. E to the power integral p1 dx. Instead of p, your new function is p1. So p1 is 2x. 2x integrating with respect to x is x square. So you will be getting e raised to x square. Therefore, general solution, that is GS, of equation 2, that is linear equation in u. U into if. If is how much? E to the power x square is equal to integral q. Instead of q, you should multiply. You should consider q1 because new function of q is q1. Just 1 second. Kindly excuse me. Is equal to q1, that is 2x into if, e to the power x square dx plus c. So how do you integrate this one? By substitution method. Put x square is equal to sum t, differentiate both sides, 2x dx is equal to dt. Some people, if they are having great knowledge about integration, they can write directly this is e power x square answer. E power t integrating dt plus c. E power t integration with respect to t is e power t, and back to original variable, that is u is nothing but y square, t is nothing but 2x, sorry x square. So y square multiplied by e raised to x square is equal to e raised to x square plus c. But our solutions not looks like that. There is no constant. Use this condition y of 0 0. So using, let us denote this is equation 3. Y value 0, comma, that is when x is equal to 0, comma, 3 gives 0 is equal to e raised to 0 1 plus c. So from this c is getting minus 1. Therefore, back to the equation 3, that is solution y square times e raised to x square is equal to e raised to x square minus 1. There is no e raised to x square in option, so we should, only one option is there. We should divide by e raised to x square on both sides, or you will be getting y square is equal to 1 minus e raised to minus x square. Accordingly, answer is option B. After dividing both sides by e raised to x square. Just 1 second. Okay, now let us go to the practice questions. The first one is, if at every point of a certain curve, this is geometrical interpretation, the slope of the tangent equals minus 2x upon y, comma, the curve is 4 options ABCD given. Slope of the tangent to the curve is usually nothing but derivative, that is dy by dx, because x and y variables are there. That slope is given, dy by dx is given. At every point on the curve, we will be getting or drawing a tangent. Tangent is a straight line. Every straight line having a slope. Slope is nothing but dy by dx in advanced level. Solution given dy by dx is equal to minus 2x upon y. This is nothing but slope of the tangent at every point of the curve. It is a variable slope. So we can separate easily. This is first order, first degree equation. So cross multiplying, just you will be getting y dy is equal to minus 2x dx, which is variables separable form, that is VSF. Then integrating both sides, we get integral y dy is equal to minus 2 times integral x dx plus constant. So y integration with respect to y is y square by 2. X integration with respect to x is x square by 2. 2 to cancel, you will be getting minus x square plus c. This can be written as x square plus y square by 2 is equal to c. Dividing both sides by c, you will be getting x square by c plus y square by 2c is equal to 1 is an ellipse. Do you all remember ellipse? Long back I told you geometrical interpretation, coordinate geometry in calculus. So comparing this c and 2c with standard form of an ellipse, denominator a square b square so this is just denoted by a square and denoted by b square. So answer is an ellipse. Let us look another question. The general solution of the differential equation 1 plus y square dx plus x minus e raised to tan inverse y into dy is equal to 0 is c is arbitrary constant. 4 options ABCD given. So in this, it's 2. This is not z. 2, number 2, constant 2. Similarly, this is 2 tan inverse y. So solution here, this is not variable separable, cannot be reducible to VSF. Now let us look the linear equation in y or x. Here, if I start with the verifying the condition for linear to y variable, y power is 2, which is more than 1. So this is not a linear equation in 1. Not a linear equation. EQ means equation in y variable. So then what to do? Let us compare linear equation in x. To write this is linear equation x, first term is dx by dy. To get dx by dy, first dividing both sides by dy and then dividing by 1 plus y square. Differential equation can be written as, let us check whether it is getting or not, linear equation in x. If we do not get linear equation in x, then the next one, Bernoulli equation in y. Dx by dy plus x divided by 1 plus y square minus e to the power tan inverse y divided by 1 plus y square is equal to 0. So shift this third term to the right side. You will be getting, this can be expressed as dx by dy plus 1 by 1 plus y square, I want to put in the bracket, into outside is x is equal to right side e power tan inverse y divided by 1 plus y square. Now this is comparing with our standard form of linear equation x. P, Q are functions of independent variable, denominator variable y. Let us say this is equation 1 is first order linear equation in x variable. So therefore IF, integrating factor, e to the power integral p dy. Now that independent variable is y. So 1 by 1 plus y square integration with respect to y is tan inverse y. Because 1 by 1 plus x square integrating with respect to x is tan inverse x. So after finding IF, general solution, that is GS, is because linear equation in x, so x into IF, that is the general solution, is equal to integral q into IF integrating with respect to y plus c. So that means x times e to the power tan inverse y is equal to q times q e power tan inverse y upon 1 plus y square into if e power tan inverse y dy plus c. Taking e power tan inverse y is equal to t, or simply tan inverse y is also can be taken as t. Tan inverse y is equal to t. Substitution method. This integration is evaluated easily by substitution method. So differentiate both sides in this substitution. Tan inverse y derivative with respect to y is 1 by 1 plus y square into dy is equal to dt. So the right side of this last step becomes e power t into e power t dt plus. So e power t into e power t is e raised to 2t integrating dt plus. So that means e raised to ax is integration is e raised to ax by a. So where t is nothing but tan inverse y. So you will be getting x times e power tan inverse y is equal to e to the power 2 tan inverse y upon 2 plus c. Any option? Yes. X into e power tan e power 2 tan. So accordingly option A. If you do not get this answer in the option A or option B, option C, D, then you should divide both sides by e power tan inverse y also. Okay. So let us go to the next examples. Next practice questions. If f of x is the solution of the equation dy by dx plus 2xy plus 2x equal to 0, that is usually the solution is nothing but dependent variable y. Instead of y, it is given f of x. Because y is a function of x, where the derivative dy by dx considered. Your solution is always a function of independent variable. And g of x is the solution of the equation dy by dx plus 2xy minus 2x equal to 0. Comma, the constant of integration in fx is equal to that in constant of in gx. Then which of the following is true? 4 options ABCD given. So actually this problem is 2 differential equations. Okay. So both are not variable separable. As earlier I checked, you also verify. Here y power 1, no other y term. It's the derivative dy by dx whole power 1. And y is not multiplying with dy by dx. So this is the first order linear equation in y. Similarly, this is also first order linear equation in y. The difference between these two, the last term is plus, here minus. Dy by dx. So this is 1 and this is 2. So 1 implies dy by dx plus 2x into y. That means implies means can be written is equal to minus 2x. Okay. So this is P and this minus 2x is Q is first order linear equation in y. So therefore IF integrating factor e power integral p dx, that is 2x dx, is nothing but e raised to x square. Therefore GS general solution is y into IF, that is y times e raised to x square, is equal to integral q value minus 2x into e raised to x square dx. The same type of integration we have got in the previous problem. So I can write this is minus e times x square plus c after taking x square is equal to t. Yes, in this problem. I mean, in this. Okay. So let us say 3. Similarly, comma, the GS, that is general solution of differential equation 2 is y times same terms, only minus 2x here. The difference plus is replaced by minus square plus same constant. Let us say 4. So just observe in third and fourth, the solutions of the given 2 differential equation, constant of integration is same. That is given. Constant of integration in fx is equal to constant that in gx. So what can you say about from 3 and 4, which are the solutions of the 2 given differential equations? Okay, from this, dividing by e raised to x square you will be getting minus 1 plus c times e raised to minus x square. And from this 4, y is nothing but dividing both sides by e raised to x square, you will be getting 1 plus c times. So this is nothing but f of x, and this y is nothing but g of x. Okay, since f of x, that is y, is the solution, SYL means solution of equation 1, g of x, again that is also dependent variable y, because linear equation in y is the solution of equation 2. That is the reason. So what is the difference between fx and gx? So if I add 2 here, for this, if I add 2, you will be getting plus 1 or not. So gx is equal to, therefore, from 3 and 4, we get gx is equal to fx plus 2. If I add 2 here, 2 minus 1 plus 1, you will be getting 1 plus c. So accordingly, answer is option D. Now the last example. The solution of dy by dx is equal to 4x plus y plus 1 whole square is, c is arbitrary constant. 4 options ABCD given. So this looks like function of the right side, which is not variable separable, function of 4x plus y plus 1. Okay, can be reducible to variable separable form. Let us say this is equation 1. Put 4x plus y plus 1 is equal to t. This is star step. So differentiate with respect to x. You will be getting 4x derivative with respect to x is 4, y derivative with respect to x is dy by dx, 1 constant element derivative 0, t derivative with respect to x is dt by dx. From this, dy by dx is equal to dt by dx minus 4. So, therefore, 1 implies, or 1 becomes dt by dx minus 4 is equal to t square. So easily separable after shifting minus 4 to the right side and bringing the t square plus 4 to the left side can be written as dt by t square plus 4 is equal to dx, which is variable separable form. Integrating, comma, we get 1 by x square plus a square, integration is 1 upon a tan inverse x by a. Instead of x, we are having t variable. So 1 by 2 tan inverse t by 2 integral dx is x plus c. Since integral 1 by x square plus a square dx is equal to 1 by a tan inverse x by a. So back to variable, t is nothing but 4x plus y plus 1 divided by 2 is equal to x plus c, which is not in the option tan inverse. Okay, so first shift this half to the right side, become 2x plus 2c, and then tan inverse on the right side becomes tan, and then multiplied by 2. You will be getting 4x plus y plus 1 is equal to 2 times tan of 2x plus 2c. So accordingly, answer is option C. I hope that everyone understood. This is by variable separable method. After that explanation, substitution method. So please subscribe the channel for getting more videos. In the upcoming weeks also, we'll be having some other topics on engineering mathematics, that is classes on engineering mathematics, live sessions, followed by technical subjects. GATEFORUM providing various courses, like number one is online classes, that is e-gate, online live classes. Number two, test series, which are of three types: chapter-wise test, subject-wise test, and gate level pattern test, that is, which is target, they're calling as target test, all the subjects in the gate pattern. And third one is refresher course. This is newly added course. In that refresh course, you will be having 2010 to 2020 all the solutions, along with materials, that is conceptual and results, note point, written notes, followed by example of each subtopic. So once again, I am requesting you, please subscribe the channel for getting more videos. So by this, I'm ending the session. Thank you, everyone. Bye-bye.